Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge IGCSE Extended Mathematics Paper 2 for examinations from 2025, and this is Specimen Paper B, Part 2 for questions 14 to 25. Okay, the first one we ended on this question here, 13. Now we go to question 14. Write 0.38 recurring. If you can look at the 8 here, it has gotten a dot. Okay, so that one there, to solve it, to put it in a fraction in the simplest form, I can let my recurring decimal to be, let's say, x. So I can say x is equal to 0.38. I can write the 8 many times that I want. So I can write up to like maybe 4 decimal places. That is equation number 1. Then equation number 2, you can see that this 3 here is the only number that is not recurring on the right. So I'll multiply through by 10. On the right, I just want a number, only the number that is recurring. Only the number that is recurring. So we shall have 3.8. So I'm going to again maintain the decimal places to 4. Okay, because these 8s are still continuing. Just put 4. Now we can see that we are having one recurring number. So since the number that is recurring is 1, then we multiply all through by 10. So 10 times 10, here you will get 100 of x, and then here times 10, you will get 38. Then 0.8, again, I'm going to maintain the decimal places here. This is the third equation. Then from there, I can get equation 3, and then I subtract equation 2, such that the recurring part goes. So we shall have 100 of x, which is equal to 38.8888, and then 10x, which is equal to 3.888 and 8. Then when we subtract 100 minus 10, that will be a 90. And then 38 minus 3, you get 35. Of course, the recurring part disappears. Then x is going to be 35 out of 90. They said give your answer in the simplest form. So in the simplest form, I'm going to use, let's say, divide all through by 5. You get a 7 here, and then by 5 here, I think we shall get 18. 7 over 18. Then number 15. Freya records how many minutes she takes to complete a crossword each day. On Tuesday, she takes 10% less time than on Monday. On Wednesday, she takes 50% less time than on Tuesday. On Wednesday, she takes 9 minutes to complete the crossword. Find the number of minutes Freya takes to complete the crossword on Monday. So I can say, here, let the time taken to complete the crossword on Monday be, let's say, TM. So that means the one on Tuesday, the time taken on Tuesday is going to be, remember, it is 10% less than that on Monday. So we shall get 1 minus the 10%. Or you can say 100 minus 10, then all through you divide by 100. That is the time on Monday. Okay. Now, this one here is 90% is the one that remains. So we shall have 0.9, the time on Monday. Then the time taken on Wednesday, okay, is going to be equal to, they are saying it is 50% less time than on Tuesday. So I'm going to have 1 minus the 50% of the time on Tuesday. But the time on Tuesday is this one, so I write 0.9, the time TM, okay? The whole of this is the time on Tuesday. The next, on Wednesday, she takes 9 minutes to complete the crossword. So this time here of Wednesday, of course, this one is going to be 0.5. 1 minus 0.5 is 0.5. Then times 0.9 tm. This is like a half of 0.9, which is 0.45, the time on Monday. And then they said that on Wednesday, she takes 9 minutes to complete the puzzle. So that means this 0.45 of the time on Monday is equal to the 9 minutes. So therefore, time taken to complete the puzzle on Monday will be 9 divided by the 0.45. Now, I can multiply. This is the same as, I can simplify this way. And I say that this is 9 over, this is 45 here over 100. See? So that means I will have 9 over 1, then times the reciprocal of this one, 100 over 45. Now, 9 goes into 45 5 times. And then 5 goes into 100 20 times. So that means our answer here is going to be 20. All right. That is that. Then we go to number 16. PQ is equal to 3, negative 1, and QR is equal to 1, 9. PQ, 3, negative 1, QR, 1, 9. Work out the length of PR. Now, it's like we are having, from P, we are having from P, then you go to maybe Q, then from there you go to R. So that vector that takes you directly from P to R. So you are going to say P to Q, then QR. Do you see that Q is common here? And in vectors, we master direction. So that means we are going to have our PR, which is equal to PQ, then plus QR. Our PQ is 3, negative 1, and then our QR is 1, 9. When we add the corresponding entries, this one will be 4, and then 9 plus negative 1, that is 8. That is what we get there. Then the length of PR, since this one here is a straight line, then we can connect these two lines like this. So to move from P to R, there is a movement in the X. So there is change in X here, and there's also change in Y here. Now, these ones form a right-angled triangle. Okay, and on a right-angled triangle, there are two things that we are supposed to use there, SOHCAHTOA and then the Pythagoras theorem for the lengths. So SOHCAHTOA is used when there is an included angle. So here we are going to use Pythagoras theorem. So the change in X squared plus the change in Y squared will give you the PR. Okay, will give us the length of PR also squared. Then we take the square root. So that means PR, the length of PR is going to be the square root of 4 squared, then plus 8 squared. This one is 4 squared is 16, and then this is 64. Okay, then we shall have this as 80. So I can leave my answer as root of 80. Okay, this is a non-calculator paper. Just leave it as root of 80. Of course, this one is going to be 8 point something because the square number that is next to 80 is 9. I mean 81, which is for 9. So this one is 8 point something, nearer to 9. So we are going to leave our answer there like that. We just say root of 80. 17. The diagram shows a sector of a circle with radius 6 centimeters. The area of the sector is 15 pi centimeters squared. Work out the perimeter of the square. Give your answer in the form a plus b pi where a and b are integers. So the first thing to do is to find the area of the sector. The area of the sector is given by the angle it subtends at the center here. Okay, there is an angle subtended at the center by this arc. So we shall first find that one there. Then we can say area of the sector is theta. It is theta over 360 because the angle sum of a circle is 360 degrees. So then times pi r squared, because a sector takes some portion of the circle, and area of the circle is pi r squared. Then this one, we shall equate it to the 15 pi. Then we shall have theta over 360 degrees, then times this is pi. The radius is 6 squared, which is equal to 15 pi. So automatically here, the pi will disappear. And then for us to get theta, I'll make it the subject. So theta is going to be equal to 15, then times the 360. Then I'll divide it by 6 squared is 36. Now 36 can go into 360 10 times. So theta is going to be 15 times 10, which is 150 degrees. Now, our perimeter, our perimeter here is going to be, perimeter is the length, sum of the lengths around the shape. So perimeter is equal to a radius. We can see a radius here, we can see another one here. And then we can see this arc here. So that will be the arc length plus the arc length. And the radius is 6, even this one is 6. Then the arc length is theta, which is 150 out of 360. Then times, an arc is part of the circumference of a circle. So we multiply by the formula for the circumference of a circle, which is 2 pi r. So 2 pi, and our radius is 6. So this one will give us 12, then plus. Of course, to simplify this, I'll take away this 0 here. And then this is 2 times 12. 2 times 6, you get 12. Now 12 goes into 36 3 times. Okay, so these 2 and the 6, they give me 12. They go here 3 times. You see that? And then the 3 here goes into this 15 5 times. So that means altogether our answer is going to be 12. Altogether we are having 12 plus 5 pi. The pi is there. Then next, we are saying part B, the sector is the cross-section of a prism of length 10 centimeters. Work out giving your answer in terms of pi. So volume of any prism is equal to the cross-sectional area times the length. So this one here is like this. Maybe there is that length there going. Then also there is this one continuing. And also there is this one which will continue down there. Okay, which is dotted. So that's how the volume is going to be. Now, volume, we get this cross-sectional area, the area of this sector, then times the length here. Now, if we come back to this one here, I say this is cross-sectional area, cross-sectional area times the length. Now, the cross-sectional area was actually given here as this area of the sector is 15 pi. So I'll have 15 pi 15 pi, and then the length is 10, so times 10, meaning altogether we can get our answer as 150 pi. The total surface area of the prism. Remember, for total surface area, we just get the areas of the surfaces, then we add them all together. Now, see what is happening here, the areas that we have. There is this rectangle here, okay? This one here going like that. It is down there. So there is that rectangle. There is also this other rectangle here going down there. Okay, then there is area of this one, this area here of the sector, but also this other side, we have that area of that sector, we also have it behind there. So that means we are having two areas of these sectors, okay? So we shall get the area of the sector, which was actually given here as 15. We multiply it by 2. Then this one here, the area of this rectangle here is 6 times this 10, and also this one is 6 times the 10. Okay. Then we have this curved surface here. Okay. This curved surface here. And how do we get that? It will actually be the length of this arc. Okay. Then times this length here. You see? So let's go back to now the question. So our total surface area, total surface area is going to be 2 times area of the sector, because there is one behind, so there are 2 of them, then plus 2 times area of the rectangle. Then there is also the curved surface. The curved surface area. Now, 2 times the area of the sector was given as 15 pi. Then the area of the rectangle, we have 6. The length is given as 10. Okay, so we shall multiply this by 2. The arc length, okay, the arc length right from here, I'm not going to waste time, right from here. We saw this, this arc here, what we got here was 5 pi. 5 pi here. What we wrote here, 5 pi, because arc length is going to be the angle subtended at the center, divided by 360, then times the 2 pi r. So it is 5 pi. Now, I'm just going to get that 5 pi here, and then I multiply it by the length, which is 10. So I'll have 5 pi, then times 10. So altogether, this one will give me 30 pi. Then 6 times 10, that is 60, times 2, that's 120. Then plus, this is 50 pi. Then when you add and simplify everything, so 30 pi plus 50 pi, that is 80 pi. Then plus 120. Or you can say 120 plus 80 pi. So that is that. Then the next question, 18, they're saying write x squared minus 8x plus 10 in the form x minus a bracket squared minus x. This is completing squares. There are 2 ways you can do this. Number 1, I'm going to show you something here. If I have, let's say, x here, I can have x, then plus, now this one is a minus here, okay, x plus a squared. When I try to open this one, it is x squared, then plus 2ax, then plus 2a squared. Then I can also have x minus a squared, which is x squared minus 2ax, then plus a squared. Now, I rearrange to put the squares on one side. So I can have x plus a squared, then minus, I can put this one here, this part, this other side. Then I will have a squared. So meaning here I will be remaining with x squared plus 2ax. The same thing that I do to this one below, which is equal, no, it's not equal to, it is a minus a squared, which is equal to x squared minus 2ax. So this part here is only having the x's. Okay, now do you realize that what is actually here, the coefficient of x is divided by 2 and put together with the x inside the bracket, and it is also popped outside here as a square. The same thing with this one here, it is here and then popped outside here, and this one is a minus. So it is the same thing I'm going to do here. First of all, the coefficient of x squared has to be 1. If it is not 1, you first factorize it. Okay, you factorize out the coefficient of the x squared. Now here it is already 1, so that means I go to the coefficient of x, I divide it by 2. So I'll write x squared minus 8x plus 10. Then I will say that will be x minus, so 8 divided by 2, you will get a 4. And then squared. Then I put a minus and then I pop it out as a square. You see that? And then this part here is for this one, just like you are seeing here. Okay, now I'm going to add on this 10 here. So add on the 10. That means this one is going to be x minus 4 squared, then minus 16 plus 10. So then your answer becomes x minus 4 squared, then minus 6. Okay, so that is that. Alternatively, someone can do this question this way. Let me rub off this. Alternatively, somebody can do it like this. They say that this is x squared minus 8x plus 10, which is equal to x minus a bracket squared minus b. Then they expand this. It is going to be x squared. So put the square on x. Then you say 2 times x times negative a. You get negative 2ax. That is the simplest expansion you can have. Okay. You just put the 2. You put the power on the x. And then you say 2 times this times that. 2 times the x times the negative a. Then you get the middle part. And then that negative a, you square it. It becomes a positive a squared, then minus b. Now, we equate the coefficients. The coefficient of x squared here is a 1. The coefficient of x squared here is a 1. We leave that. Then, the coefficient of x here is negative 8. This other side, the coefficient of x is negative 2. That means for me to get a, I will say negative 8 divided by negative 2, and then a becomes a 4. Then the constant part here is 10 here. Then this way the constant is a squared minus b. So bring the b this side. The constant part is the one that doesn't have the x. Okay, b is equal to a squared, that is 4 squared. Okay, then minus, take the 10 this side, minus 10. So this is 16 minus 10, which is a 6. Then now you can write, you just put these values, okay, these values in this formula here, in this expression. So a, you put 4, and then where b is, you put 6. So that is that. Next, sketch the graph of y is equal to x squared minus 8x plus 10. On the sketch, label the coordinates of the turning point. Now, for turning points, dy dx is equal to 0. You can use differentiation, but if the first part they have given you to express this in the squared format, in the completed square format, you don't have to waste time. The turning point, you get it from here. The x coordinate here, which makes this one a 0, will be 4. So you get this one and you equate it to 4. I mean to 0. So x will be a 4. So the turning point is going to be that 4. And then this is the y coordinate, which remains. So that is 4, negative 6. Now I come to this one and I label the 4. Maybe 4 is here. Negative 6 is around here. So I can put this one here. And then they are saying the coordinates of the turning point. That turning point of ours is 4, negative 6. And then the y-intercept. The y-intercept, that is where the graph cuts y-axis. So on y-axis, you know that on y-axis, okay, x is equal to 0. So when I substitute in our equation given, this is 0, this is 0, then we shall get a 10. So y is equal to 10. That means I come to this graph and then maybe I put this is my 10 here. And because the coefficient of x squared here is a positive, it is 1, this is a U-shaped curve. Okay, if the coefficient of x squared is a negative, that one will be an N-shaped curve. So this one is going to be U-shaped. So I will draw something like this. I will come to this. And then continue like that. So that will be the sketch. They didn't tell us about the x-intercept, okay, where it cuts the x-axis, because that requires the solution of this quadratic equation. Okay, that is that. Then we go to the next. And by the way, to prove that this is actually the turning point, this 4, negative 6, let's check. When we are finding turning points, we differentiate. And we know that if you have y, if you have your y, which is equal to x power n, then dy dx is equal to, drop this power down here, you get n, then x, then you reduce that power by 1. Now, when we differentiate what is here, dy dx is going to be, drop that power 2, so it will have 2x, then we reduce the power by 1, then minus, of course, 8 here, okay? Because we are having 8x power 1, so when this one drops, and then you reduce it by 1, x will remain with the power 0, and any number to the power of 0 is, any number to the power of 0 is always 1. So that is the one there. And of course, the constant disappears because 10 is the same as 10x to the power of 0. So when you drop this one here, I will have 10 times 0, then x power 0 minus 1. So the fact that I've multiplied by 0, it implies that the whole thing disappears. So whenever you differentiate a constant, you get a 0. Then for turning points, this one is equal to 0, the dy dx. Now, solving for x will be, you take the 8 this side, then you divide it by 2. This one will be a 4. So when you get this 4 and you substitute here, 4 squared, what will be our y? Minus 8 times 4, then plus 10. So we shall have 16 minus 32, that is negative 16, then plus 10 will give us negative 6. So you can see that the turning point is 4, negative 6. But when you complete squares, this one here, you just get this one in the bracket, you equate it to 0. Okay, you get the x coordinate. Then what remains outside here is always the y coordinate. That is the turning point. As simple as that. Next, a point P lies on the graph y is equal to x squared minus 8x plus 10. The gradient of the graph at P is 6. Find the coordinates of P. So the gradient function of any graph is the dy dx. Remember, differentiation is the process of finding the gradient of the curve. So from actually our previous working here, our dy dx is 2x minus 8. So I will say that dy dx is going to be equal to 2x minus 8. Now this is the gradient function. Now this gradient function is equal to this 6 here at that point, because they say the gradient of the graph at point P is 6. Then solve for this x here. 6 plus 8, that is 14. Then when I need x, it will be this 14 here. Then I divide by 2, which will be a 7. Now when x is 7, what is y? Because they said the coordinates, so that means we need to get the x coordinate and then the y coordinate. Then we can put 7 here, we square it, then minus 8 times 7, then plus 10. This is 49 minus 7 times 7 is 49. Now 7 times 8, you just get 49 plus the 8. Plus the 7. So you will get 56, then plus 10. Now 49 plus 10, that one gives us 59. 59 minus 56, I think that is a 3. That means our answer is going to be 7 and then 3. That has been it for this question. Then we can go to the next one here. Number 19. This one is from SADS. And this is the year where they have brought the SADS. They have always left them out. So simplifying SADS, numbers of the sort, you need to split the number into 2 parts. Okay, into 2 numbers, where one is a square number. So 75. But when you look at this, by the way, when you look at what is given here, there is a 3. That means there has to be a 3 in here. So 75 divided by 3, that one gives you 25. Now, you will say that this one is 25 times 3, and you can see that 25 is a square root. Is a square number. Then root of 3. And then here I will have root of 25, then plus, times root of 3, then minus this root of 3. Root of 25 is 5, root 3. And then SADS are said to be added or multiplied if the number under the square root sign is the same. So the number is the same, 3 and 3 here. That means we can simplify them. So 5 minus 1, that one will give us a 4. So that means I will have my answer as 4 root of 3. That is the simplified one. Then part B, rationalize the denominator and simplify. By the way, this question here, this is the same way that you can say express this in the format a plus b may be root c. That is the same setting. So what we do, to rationalize the denominator, we get the conjugate of the denominator, we multiply it by the numerator and the denominator. It's like we have done nothing. Okay, so we have 1 minus root of 5, and then here 1 minus root of 5. Then I put here 1. It's a plus, by the way. It's a plus. So the conjugate, if you have a plus root of b, the conjugate of this one is going to be a minus root of b. So the part which has gotten the square root is the one you change its sign. Many times they can give something like this, let's say root of 5, and then they say like plus 2. And then for you, when you are multiplying, then you use root of 5, then minus 2. No, it has to be the square root whose sign you change. Okay? Keep that in mind. Now, we multiply all through. This one I can even leave it, and then I simplify what is down. Then I see whether it can simplify the 8, because they say then simplify. Okay. Now, in identities in algebra, we have a squared minus b squared, which is equal to a plus b, then a minus b. That's the difference of 2 squares. So don't you think that is what we are having here? It's exactly what we are having there. So what we are going to do, you just get that denominator. You don't need to waste time. You just get the denominator and you say 1 squared, put a minus, then that root of 5, you also square it. So we shall have 8 into 1 plus root of 5, then over 1 minus 5. Root of 5 is the same as 5 power half. Now when I square, you know, in indices, these powers are going to multiply. So a half times the 2, then this one goes, and then you have 5 power 1. So that's why I have 5. And then here we have 8, 1 plus root of 5, then out of negative 4. Now that is negative 4. So negative 4 here goes in 8. 4 goes in 8 2 times. So that means I can have my answer as negative 2. You can have it as negative 2 into 1 plus root of 5. Or I can open the brackets and then I write negative 2 minus 2 root of 5. As simple as that. Next, 20, expand and simplify. So you can get the 2 brackets. These 2 brackets, you expand them and then you multiply with this. So here we are going to have 2x. So 2x times this x, we shall get 2x squared. Then 2x times this one, we shall get 2x. Then negative 3 times x, we shall get negative 3x. And then negative 3 times 1, we get negative 3. Okay. And then here we are having 2 minus 3x. And then to simplify this, it is going to be 2x squared minus x, then minus 3. Okay. 2 minus 3, that is a negative 1. Now, whatever is in this bracket must multiply with whatever is here. So we are going to have 2x here. In fact, let me just expand it this way. 2x squared must multiply with 2 minus 3x. Okay? Then there is a minus x here. We'll also multiply with the 2 minus the 3x here. And then also we have a minus 3 has to multiply with the 2 minus 3x here. That means when we multiply here, we shall get 4x squared. Then 2x squared times minus 3x, that one will give us negative 6, then x cubed. And then here we shall have minus 2x, minus x times minus 3x, that will be a positive 3x squared. Then minus 3 times 2, that will be a minus 6. Minus 3 times minus 3, that is a positive 9 of x. And then when we simplify this whole thing, we shall get in the decreasing powers of x. So we have negative 6x cubed. And then x squared, we are having 4. And then this, that is 7x squared. And then x is this 9x. And then minus 2, that will be a positive 7x. And then there is this minus 6 here. Minus 6. So that is that. Then next, number 21. Number 21, the diagram shows 2 right-angled triangles ABC and ACD. The value of cos, find the value of cos ADC. ADC. So they want cosine of that angle. Now, if this is the angle here, this is the side which is opposite to it. This is the side adjacent to it. And this is the side which is hypotenuse. And then to the 30 here, the side which is far away is the opposite. So the opposite, and then the adjacent is the one which is nearer to the angle or perpendicular to the opposite side. Then this one now will be the hypotenuse of this 30. Okay. Now, in fact, let me just take away this one, and I write them in this color. So for 30, this will be the adjacent, and this will be the opposite. Now, for any right angle triangle, we are supposed to use SOHCAHTOA and then the Pythagoras theorem. Okay, SOHCAHTOA and Pythagoras theorem. Now, the diagram shows two right angle triangles ABC. So now, we need two sides to find the angle. So since we are given 30 here, then we can find, can use SOHCAHTOA. This is opposite. I need opposite and hypotenuse. This opposite here, this hypotenuse here for 30 is going to be the opposite for this angle. So I need it. Okay. That means we are going to, using SOHCAHTOA, we are going to have, there is opposite and hypotenuse. So sine of 30 degrees. Remember, we are using SOHCAHTOA. So sine is opposite of hypotenuse. So the opposite is 6. The hypotenuse is the one that I'm looking for. So we cross multiply here. Our hypotenuse will be equal to 6 over the sine of 30. Sine of 30 is a half. So you have 6 over a half, which is equal to 12. Now, there are people who don't know how to find these exact values of this. Let me take you through this calculation here. What we are going to have, we can use those angles, 45, then 30, and then 60. So for 30, we get it using using an equilateral triangle. So this is, if I may say, this is the equilateral triangle. Okay. Then I can put the height here, the perpendicular height here, and the whole, all the lengths are equal. So I can have, let's say this is 1 unit, 1 unit, 1 unit, just to simplify the work. So if this one is also 1 unit, that means this one can be a half and this one can be a half. So since this one is an equilateral triangle, we can have 60 degrees here. This one is 60 degrees here. Even up here, it is 60 degrees, but divided into 2, this will be 30 degrees and then 30 degrees. Now, we need to get this height here. Okay. Now, this is a right angle triangle. I can use Pythagoras theorem. So we can have h squared plus a half here squared, which is equal to 1 squared. That means my h is going to be the square root of 1 minus, take this a half this side squared, it is 1 over 4. So the whole minus a quarter, you remain with 3/4, okay? 3 over 4. We put the 4 here, then minus 1 over 4. That means here we can have root of 3, then over root of 4 is 2. So sine of 30 degrees is going to be equal to the opposite. So the opposite to this angle here is this half here, opposite over hypotenuse. Hypotenuse is 1. So over 1. That is how I come to know that sine of 30 is 1 without using a calculator. How about cos of 30? Cos of 30 is adjacent. This is the adjacent to the 30, which is root 3 over 2. Then divide by the hypotenuse is 1 here. That means cos of 30 is root 3 over 2. When you're using a calculator, that is the one which gives you 0.866 and the rest of those figures. And then what is tan of 30 degrees? Tan of 30 degrees is the opposite is here, which is a half. And then the hypotenuse is this. Opposite is a half, then over adjacent. The adjacent is this h here. So which is root 3 over 2. So this one can be like a half times the reciprocal of this denominator, so 2 over root 3. The 2 can disappear, and then you get your answer as 1 over root 3. How about for the 60s? You can have sine of 60. Sine of 60. Now the opposite is here, the h, which is root 3 over 2. And then divide by the hypotenuse is 1. So we have 1, that is root 3 over 2. And then cos of 60. cos of 60 is going to be adjacent over hypotenuse. So adjacent is a half, and then hypotenuse is 1, so it is a half. And then tan of 60 degrees is equal to the opposite, which is this h here, root 3 over 2, divided by adjacent, which is a half. So this is the same as saying root 3 over 2, then times 2 over 1. So this one goes, and then you have it as root 3. And on the look of things here, I want you to pay attention to sine of 30 is a half. Cos of 60 is also a half. Cos of 30 is root 3 over 2. Sine of 30 is root 3 over 2. Okay? So this implies, and these angles add up to 90 degrees. So we can have a formula here that sine is very important. That sine of an angle is equivalent to cosine of that angle of 90 minus that angle. Okay? Cos of 30, then here 90 minus 30, that is 60. So, sine of 30 is equal to cos of 60. You see that? And also, cos of theta is the same as sine of 90 minus theta. You can try it with your calculator. Any of two angles which can add up to 90 degrees. The cos of 40 must be equal to the sine of 50, like that. Okay? And then also for 45, we see it is the same. Now for 45, let me also have a right-angled triangle here. A right-angled triangle here. I'm assuming a right-angled isosceles triangle. So this is equal to that. Let's say it is 1 unit, and this one is 1 unit. Okay? So since these two are equal, that means these two angles are equal. So we shall have a 45 here, and this one is a 45. Because these two angles are equal, and they must add up to 90 already. We have 90 here. So we need another 90 to make 180, and these are the two angles. Now, what is now sine? Sine of 45 is equal to the opposite. Opposite to this 45 is this one here, which is 1. Then over the hypotenuse. Now we need to find this one. We can use Pythagoras theorem. 1 squared we have here, plus 1 squared here. Plus 1 squared. That will be 2. So this is root of 2. That means sine of 45 is going to be 1, which is the opposite, over the hypotenuse, root of 2. Okay? 1 over root of 2. That is 1 over root of 2. On smart calculators, actually, they don't write this. They write root 2 over 2. How does it come about? They multiply this. Remember, surds, you don't write them in the denominator. So we multiply it down and up. It's like we have done nothing. Now, root 2 times root 2, you get a 2. So it is the same as root 2 over 2. Even cos of 45. Cos of 45, that is adjacent, which is 1 over hypotenuse. So do you see that it is also the same as root 2 over 2? Now, is this one correct? When I say that sine of theta is equal to cos of 90 minus theta, sine of 45 would be equal to cos of 90 minus 45, which is also 45. So you can see that cos of 45 is equal to this, and also sine of 45 is equal to that root 2 over 2. How about now the tan of 45? Tan of 45 is opposite over adjacent. So it is 1 over 1, which is 1. You see? So that is that. Now going back to our question here, find the value of cos of this. Now, remember, we had found our sine of 30 as a half. So the 2 will go up, and then it multiplies with that, because it is going to be 6 over 1, then times. The reciprocal of a half is 2 over 1, which is 12. Then we continue. We have now this triangle here. So this part here is 12, and this one is 9, then this is theta. So we have now the opposite and the adjacent. This, the side which is far away, is the opposite. Then this is the adjacent. So opposite and adjacent, using SOHCAHTOA, we shall take the TOA part. So that one is going to be now tan of that angle. No, they asked for the cosine. Okay. Now cosine is going to be the adjacent over hypotenuse, this hypotenuse here. So we need the hypotenuse. That means our hypotenuse using Pythagoras theorem is going to be the square root of 9 squared plus 12 squared. Okay. 9 squared is 81 plus 144. Okay. This is 81 plus 144 plus the 81. You will get 5. And then this one is 20. This is 12. Take 1 here, 2 to 5. So root of 2 to 5 is actually 15. So meaning we are having our right angled triangle here. This is 15. The opposite here is 12. This is 9. This is the angle here. So we shall say cos of angle ADC, which is equal to the adjacent. The adjacent is this one, 9 out of hypotenuse, which is 5. This will be our answer, which we can even simplify, and we write by 3. By 3 you get 3. By 3 you get 3. Then by 3 you get 5. So it will be 3 over 5. That is that. Then next, this is number 22. They are saying in this question, all lengths are given in centimeters. Triangle ABC is mathematically similar to triangle ADE. Show that 2x squared plus 15x minus 50 is equal to 0. So we are having two triangles here which are similar. Okay. We have the big one. Okay. The big one. And then we have the smaller one. So we are going to have, for the big one, this whole length is 7. Sorry. This is going to be 7.5. Then we add x plus 5. And then this length here is 2x. And then this way we are having 10. Okay. Oh, no. It's very wrong. This is the smaller one. So that means here we are having x plus 5. And then for this one, it will be 7.5, then plus the x plus 5. Now, show that that is equal to, so for similar shapes, the corresponding angles are equal, and then the corresponding sides are all in the same ratio. So we can have 2x. I can say 2x here. I divide by the corresponding side is this one here. So I can have over 10. Then it's equal to, I come back to this one. If I started with the smaller one, then I have to come back to the smaller one. X plus 5. Then we divide by, this one is going to be 7.5 plus 5. That will be 12.5. X plus 12.5. Then we can cross multiply. So 2x times, we shall have 2x here times x plus 12.5. And then 10 times x plus 5. And then after that, open up the brackets. So this is 2x squared, then plus 2 times 12.5. That will give us a 25 of x, and then here we have 10x, then plus 50. And then we bring everything this side, so we shall have 2x squared plus 25 of x, subtract 10x, subtract 50, then everything is equal to 0. So meaning all of it together simplified will be 2x squared. 25 minus 10, that will be a positive 15 of x, then minus the 50. And that is what we are told to show here. Next, solve by factorizing. So for factorization, we need to get the sum. Okay, the sum here. The sum is the middle number here. So our sum is 15. And then the product is SC. For any quadratic equation, which is ax squared plus bx plus c, our sum is equal to the b, and then the product of the roots is going to be a times the c. So our product here is going to be equal to 2 times the negative 50, which is negative 100. Then you look for two numbers. When you multiply them, you get negative 100, but then when you add them, you get 15. Of course, that has to be 20 and the 5, okay? So since the sum here is very small, I mean the product is negative, that means one of the numbers is negative. So we shall put the negative on the 15, so that when you get 20 plus negative 5, you get the 15. Then these two numbers you have gotten, you put them in the place of the b here, in the place of the 15. So 2x squared, then plus 20x minus 5x minus 50 is equal to 0. Then 2x here is common. So out of the 3 terms, now I've gotten 4 terms. Now I can split it into 2 and then I factorize accordingly. So 2x here is common, then we shall remain with an x here, and then 20x divided by 2x, you will get 10. Then after getting the first bracket here, I don't waste time. I just come here and I open that bracket again here. Then I ask myself, what should I multiply with the x to get the negative 5x? It will be a negative 5. In other words, negative 5 is common here. Then x plus 10 is common, so I put it out here, meaning what I'm remaining with here is 2x, and then what I remain with here is negative 5. Then for me to get a 0, that means I can put a 0 here, then a 0 here, I multiply with this to get a 0. So that's why we get these factors and we equate them to 0, then x becomes a negative 10, and then we also get this 2x minus 5, you equate it to 0, then x becomes a 5 over 2. So we can have the 2.5, okay? I can write 2.5 or 5 over 2, no problem. And then this is negative 10. Then next, they are telling us to find the length of SC. When you look here, the length of SC here, if I take the x value here as a negative, if I take it as a negative here, that means we will remain with negative 5. And length cannot be a negative. So we dismantle the negative, we take the positive one, okay? So SC is going to be 7.5. SC is equal to 7.5, then plus x. In fact, it was 12.5. I don't need to waste time here. This is 12.5, then plus the x value we have gotten as 2.5. So that one will give us, I think that is 15. Yes, it has to be 15. So that is 15. That has been it. Then we continue to the next one here. This one here. The area of triangle ABC is k centimeters squared. Find an expression for the area of the quadrilateral BCD. Okay, area of the triangle ABC. Now, area is given in square units. Okay, square units. Now, they want us to find an expression for the area of quadrilateral BCD. Let us first go back to this one. I think I need to remove it because I'm already done with it. Yeah. Okay. Okay, so we are going to use the scale factors of enlargement here. So the next one here, area scale factor. Okay, we have area scale factor is equal to area maybe of the big one over area of the smaller one over area of the smaller one. And then we also know that area scale factor is equal to length scale factor squared. Okay, now going back to this question here, this first part, the linear scale factor here is what this expression we used here. Okay, here. So 2x over 10. Remember, our x, we took it as 2.5. Okay, 2.5. Then now times 2 over 10. That is area of the smaller one. Okay, over area of the bigger one. So this one is going to be 5 over 10, which is actually a half. So meaning area of the bigger one is twice area of the smaller one. You see that? Because this part here is for the smaller one, 2x, but we are supposed to say area scale factor is equal to the one of the bigger one, which is going to be 10, then divide by the 2x. Okay, now 10 over the 2 times 2.5, this one will give us a 5. So 10 over 5, that is a 2. So the no, this is not area scale factor, it is linear scale factor. Pardon me here. This is the length scale factor, which is 2. That means remember, the lengths are given in units, but then the area is given in square units. So meaning the area scale factor is 2. Okay, then we square that. Okay, we square that, then which is going to be equal to find an expression for the area of the whole quadrilateral. So this one they have given us is for ABC. Then I need to get, where is ABC? ABC, that is for the bigger one. Okay, it is K. Then we shall divide by this one of the smaller one. So we need to have it. The smaller one here, coming back here, I will have area of the bigger one is that K. Then area of the smaller one, we don't know it. Okay, so we cross multiply. That means area of the smaller one is going to be K, then over 4. That means area of the quadrilateral BCD, when you check here, of area of BCED, it will be area of this big one minus area of the smaller one. So the area of the big one is K, then minus this one we have gotten. So that simply implies that we are going to have area of BCED is going to be area of the bigger one, which is K, minus area of the smaller one, okay, which is K over 4. So 1 then minus a quarter, those are 3/4. So that means our answer is going to be 3 over 4 of K. Then number 23 is from sets, and in the Venn diagram shade the region P union Q complement union R complement. Now, you are going to shade P, the whole of it, the whole of set P. Union is to put all things together, okay? That is set P shaded. Then Q complement, that is outside of Q. Outside of Q, it is here. Outside of Q is all of this. This is all outside of Q. You see that? Then another one is outside of R. R complement, outside of R. So we have this, the whole of it, and everything outside of R. So then there is this one which I've already shaded. So that means this is the only part which remains unshaded. Okay, then next, number 24, rearrange the formula to make P the subject. So to rearrange, you can cross multiply because this is division. Remember, in rearrangement, we undo operations. So this will be D times 2 minus PY, which is equal to then 2P plus 3, open brackets, 2D minus DPY, which is equal to 2P plus 3. We are making P the subject, so that means you put the terms that have gotten P on one side. So this is 2D, bring the 3 this side, it will be a minus 3, and then when you take this one this other side, it will be a plus. So we shall have 2P then plus DPY. Then factorize out the P, we shall get a 2 here and then dy here. This side we have 2D minus 3. Then automatically we shall divide through by this one here, 2 plus dy. We also divide it here, 2 plus dy. So our answer is going to be 2D minus 3, then divide by 2 plus dy. Then next, I think this is the last page of the paper. We are having simplify 2xy power any number power 0 is always a 1, and this power is going to go on all of them, okay, on all of them. So that means we can have something like this: 2 power 0 times x power 0 times y power 0. So it is 1 times 1 times 1. Automatically your answer has to be a 1. Then here we are also going to have 81, which is actually 3 power 4. And I can first simplify what is inside. Let us first simplify what is inside. 3 goes into 81. 81 here, divide by 3, you get 27. By 3, you get 9. By 3, you get 3. By 3, you get 1. So it is 3 power 4. So that means 1, 3 goes, you have 3 of them. That will be 27. So we can have 27. Then m power 8 over m power 2 will be m power 8 minus 2. That is m power 6. Then we have m power 6. Then this one here. Now, this 27 is 3 power 3. It is supposed to have this power 2 over 3. And then you also have m power 6. It is also supposed to have this power. Okay? Because we have a rule in indices that a, b, then power x is going to be a power x, then b power x. So then we multiply. We have a power b power c is the same as a, b, c. I mean power b times c. So that means I will have 3 here, then 3 times 2 over 3, and then m power 6, then times 2 over 3. So this one automatically will cancel that, then this one goes here once, then here 2, and then your answer becomes 3 squared, which is 9. You don't write 3 squared, you write 9. Then m, the power is going to be 2 times 2, that is a 4, so m power 4. Then find a value of x here. Now, the number 32, the number 2, and the number 4 are all powers of 2. So I can write them as powers of 2. So, and 32 is 2 power 5. 2 times 2 times 2 times 2 times 2. And then this is 2 power x plus 3. And then 4 is 2 squared. Then here, using this rule, a power b times a power c, the same bases, then you add the powers p plus c. That means we shall have here 2 power 5 plus x plus 3, then is equal to, we also have 1 over a power n is a power negative n. So you take this one up, then it will be 2 power negative 2. The power becomes a negative. So this is 2 power 5 plus 3, that is 8. So x plus 8, which is equal to 2 power negative 2. Since the bases are equated, that means even the powers are the same. So x plus 8 would give us negative 2. So you take this one this side, and x is going to be negative 2 minus 8, which is actually negative 10. So that has been it for this paper. Thank you so much for watching. May God bless you. Please, if you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.